Welcome to Tetryonics. This is the third lecture in the series covering the Tetryonic rebuttal of special relativity. This lecture particularly concentrates on fields of force as described within quantum electrodynamics and relativity theory. It forms part of the Tetryonic ebook series and particularly relates to information illustrations contained within Tetryonic Book 2, Electrodynamics. It's available on YouTube and Google Plus or upon request. Within Tetryonic theory, all force and mass, matter and energy are derived from the equilateral geometry and forces exerted by Planck's constant. Planck's constant, of course, is the quantum of action, or the minimum quanta of work, and through the charged geometries forming larger and larger concentrations or energy densities of Planck quanta within any region of space or time, they can effect force at a distance or force locally in the case of its energy momenta. In the case of Planck's constant, there are two energy momenta resulting from its equilateral geometry. The first is its quantized angular momentum, drawn here as a vector rotation within the 0-point field. This is an illustrative model only of the energy flux within a 0-point field. It models the energy flow within a short-circuited ideal quantum inductor, where the inductor itself, with energy flowing through it, will create a magnetic dipole within the inductor. Obviously, the direction of energy flow within the inductor will create either a south-north or a north-south dipole, dependent on the flux. In reality, this vector rotation, as it's drawn electrically, is in fact the result of the equilateral square geometry of Planck's constant. This in turn creates a charge, or a measurement of mass time in the energy geometry, mass obviously being a measure of the energy content and time being the angular momentum per c squared, or the quantized angular momentum per c squared. Of course, if you take alpha divided by c squared, you get the quantized charge of Coulomb's constant, or the elementary charge in the case of the electron, 1/12 of the elementary charge of an electron or proton. Of course, we can also take the square root of the equilateral square geometries of energy, and in doing so we generate a measurement of the linear momentum of the system, classically expressed as mass velocity. In both cases where charge is present, or through the geometry of Planck's constant, we have a situation where either side of the Planck's constant will have a differing charge. One side will be positive and the opposite side will be negative. It's through this differentiated charge within the Planck quanta themselves, as they come together to form larger scale mass-matter geometries, that creates the fields of force familiar in quantum electrodynamics, and as described by Faraday, Maxwell, Einstein, Hawking, Dirac, many of the notables, Feynman. They've all attempted to explain the fields of force discovered by Faraday mathematically. Obviously, as we've discussed in the previous lectures, particularly the last two, modelling things mathematically may fit the observed phenomena, but it's not an appropriate, extrapolating from the mathematics is not always appropriate as far as in an attempt to understand what the underlying physics is, in this case the underlying geometry. The two charged sides of Planck's constant give us all our fields of force, and they give us all forms of mass, energy and matter in the universe. You can look at this another way and say that within empty space, everything we can see, sense, touch, taste and smell and observe and measure comes from a single equilateral energy geometry. In this case it's Planck's constant. Obviously 1 Planck's quanta per second is a measure of energy, kilograms square meters per second squared. And this is how Planck discovered the quantization of energy to formulate quantum mechanics. Tetryonics takes the quantum mechanics approach one step further with quantum geometry and shows that the equilateral geometry is in fact the square numbers of physics. So everything within our universe, save the field of measurement or the spatial coordinate system, is the result of these equilateral quanta coming together in their various forms. And this includes not only mass, energy and matter itself, but the forces that are exerted between these forms of energy. And this is where we'll concentrate in this lecture. As I've mentioned, within physics and particularly quantum mechanics, the square number energy fields, or the quantum levels as they're occasionally called, are in fact not square geometries, they are equilateral geometries. This is an oversight that has existed since Plato or even early Greeks, possibly earlier. All our mathematics is formulated obviously on the fact that square numbers are square geometries. Tetryonics rewords this to say that square numbers are equilateral geometries. In this case, we can see that a triangle is an equilateral, as is a square is an equilateral, and a hexagon is an equilateral. They have equal length sides and the same angles within their geometry. A circle is also the same, but it has obviously no angles except for its total 360 degree radius that it forms. It's not normally considered to be part of the polygon series, as it only has one edge, whereas typical polygons from their name have more than 2 edges, with the triangle, specifically the equilateral triangle, being the first polygon. It's unique in that obviously within the triangle it only forms 180 degrees, not 360 like the others. So it would take 2 equilateral triangles to form 360 degrees, or a tau geometry if you express these as pi geometries. As we note within Tetryonics, the square numbers form from equilateral energy geometries, with the square number scalar energy fields being comprised of odd number energy geometries or bosons. And as we've mentioned, the square root of these fields is the linear momentum, whereas the equilateral geometry of the field is its quantized angular momentum. We'll now quickly cover some of the basic, or recover some of the information that was given in the past 2 lectures, so that we can continue on with our understanding of force and energy distributions. We of course explained in the previous lecture the Tetryonic geometry of electricity and electric fields, where it's the energy quanta of separated charges, or the energy per charge, that gives us a measure of voltage. Again, it's the equilateral charged energy geometries of mass energy that gives us matter geometries. And of course we have positive and negative charges resulting from Planck's constant. As we'll discuss further in this lecture, where the 2 fields, electrostatic fields or chem fields of particles, either static or in motion, superposition, we create fields of force between the particles, and these are subject to the law of interaction, where opposites will attract and similars will repel. Again, we'll show how the equilateral energy geometries creates these fields of force in this lecture. And as we mentioned with Tetryonic laws, the second law of Tetryonics is that energy in all its forms seeks equilibrium, whether it's seeking charge equilibrium or mass energy density equilibrium. In all cases where you have separated charges or voltages and you connect them, they will seek to equalize out, and in doing so create an electric field that in turn will create current within that conductor. And of course, in the case of charges in motion themselves, it's the chem field of the charged matter that's subject to frequency and wavelength contractions due to its motion. The mass matter itself is invariant as it's a standing wave. And measurement of these charged particles, be they electrons in this case or ions, constitutes electron current flow or conventional current flow. As we show here, electricity itself, when a conductor is placed between two separated charges, creates an electric field or a field of electricity between the two separated charges as they seek to equalize. This flow is near instantaneous. However, once it's established, any unbound or free electrons or charged ions within that conductor then are in a situation where they're subject to the charged or the convergent and divergent energy momenta in the field of electricity and begin to be accelerated. Of course, the energy of motion from the force exerted on them by the electric energy momenta is in fact stored relativistically within their chem fields. And as their velocity increases, so does the square number of quanta required to achieve that motion, and accordingly so does their magnetic moment. We can achieve these accelerations through the use of electricity, where we simply separate charged fields or charged geometries, in this case two plates. We can do this in batteries or using a generator where we convert rotational work into charge and separate those charges. As we increase the available energy momenta per charged plate, we increase the voltage that is available to do work. And of course, when we complete that circuit, again, the electric field will flow through the conductor, inducing a motion in the free electrons or ions present in the circuit. We showed in the previous lecture how the electromagnetic induction, or the exchange of energy from one circuit or one object to another, is done through bosons, specifically odd-numbered energy momenta quanta. These are transverse geometries as opposed to the linear geometries, even-numbered geometries of photons. So the same field measured transversely will give us a measure of the bosons, normally expressed in Tetryonics as E equals h nu, versus a measurement in the longitudinal direction, which will give us a measurement of photonic energy, again expressed in Tetryonics as E equals hf for frequency. 2 quanta makes a photon quantum, and accordingly both bosons and photons will always add up to square numbers within the chem field or any energy field due to the equilateral geometry, and this is expressed as E equals h nu squared. Again, the nu squared is proportional to the velocity. As the velocity increases, so does the energy momenta quanta within the field. This field is obviously made up of kinetic energy and a magnetic moment for the particle in motion. And again, the orientation of the magnetic moment dipole is determined by the net charge of the matter in motion. In this case, it's an electron, so it will be a negative field, with this left-hand side being a south pole and the right side being a north pole, in line with the south-north geometry of equilateral charges. Or again, you can model using a vector rotation about a point to model these short-circuited quantum inductor geometry, in which case it'll be a anti-clockwise rotation or flux of energy within that geometry. And again, this charge in reality is not a rotation or a flux of energy. It's that is an electrical equivalency, to relate it back to classical electrical engineering terms. It is in fact derived because of the imbalance that's present due to the equilateral geometry. As the square number of quanta build up within the field, there will always be an imbalance due to this equilateral geometry between the positive and negative charges. As we increase the energy density of the field through either a force or its increase in velocity, both of which are related through F equals ma, Newton's second law, we of course change the energy momenta quanta within the chem field. Nothing changes in the standing wave mass matter geometry of the lepton in motion. So we again show that all inductive transfers of energy occur first through bosons or half wavelength photons, and then these in turn can combine to form photons of energy or spectral colors, light, etc. We also showed how we can use the equilateral geometries at a foundational level to re-express and re-explain the forces between particles in motion within a conductor, normally expressed as Ampere's law, etc. We can either draw them physically as they really are in Tetryonics from the theory, or we can simply develop a stylized model of a chem field reflective of its charge and direction of motion of the particle. Again, because the magnetic moment is what the Lorentz force in this case is expressed through or created by, we can use the magnetic moment of each field in its direction of motion to give us the interaction of the Lorentz force. Of course, as we increase the energy quanta in proportion to the velocity of each particle, the strength of the field will change. And again, these forces are created through the superpositioning, in this case, of magnetic fields, whereas that's in Lorentz's force is a superposition of magnetic fields. Coulomb's force between charged particles in motion is the superpositioning of electric permittivity fields, or E fields. We described the geometry of photons themselves against what relativity theory expresses them as. In fact, we can accelerate ourselves to the speed of light and see the equilateral geometry that makes up a photon or a EM wave. And this is what we would see. We would see a neutralized E field pairing and a strengthened magnetic moment as a result of this opposite charge E field pairing. Again, the photons are formed through the inductive coupling of the two 0-point fields, and then they form EM waves by the magnetic interactions and E field interactions from one photon to the other. We can of course measure these, the frequency and wavelength of these fields, and they are also subject to Lorentz corrections due to their velocity, although in the case of EM waves they more than likely travel at the speed of light in a vacuum. This will change if they go through a medium. But again, the classical formulation for the energy of the photon, which is in fact all kinetic energy, is mv squared, or 2mv squared, because of the two quanta. And again, we can quantize that using Planck's constant and the equilateral geometry of the field and calculate for its scalar energies. Of course, again, measured transversely, it would be h nu for the boson or quantum levels, or HF in the longitudinal direction, as a measure of the photonic energies, specifically the E field excitations, etc. We of course showed the relationship between frequency and wavelength in the previous lecture and expressed it as a velocity. We did so that the speed of light no longer needs to appear in the equations. We simply state the frequency as a scalar measurement of the energies and the wavelength as a linear measurement, or the square root of the energy fields, giving us a velocity relationship between the frequency and wavelength. And again, this varies from one medium to the other. But in doing so, using the equilateral geometries, we of course showed that all the formulations of Newton, Leibniz, Maxwell, Planck, Einstein and de Broglie with regards to energy, momenta, wavelength, frequency and mass are all in fact different measurements of the same Planck quanta within any region of space-time, or any region of space. Should drop the term space-time unless you're specifically referring to the charge. Space-time is a measurement of spatial geometries within any region. Space is just a region of or a volume of defined by a unit of time. Again, one interrelates with the other, and without the geometry it can be very confusing. Of course, the previous lecture clearly showed that wave-particle duality is simply the result of chem waves creating motion for particles of mass matter, hence the term wave-particle. This of course can also be applied in the case of transverse versus longitudinal measurements of chem waves themselves, where you could refer to the transverse measurement as a wave and the photon as a particle of EM energy. But more appropriately, and as defined in Tetryonics, we define them distinctly as a wave being two-dimensional Euclidean mass energies and a particle being three-dimensional standing wave geometries of mass matter or mass energy matter. Again, particle with a capital P referring to matter, as opposed to the wave referring to the mass energies of the 2D wave. Of course, we can't see these 2D waves because they're two-dimensional, and all we can detect them through is either their quantum electric and magnetic fields or the force that they can exert over a distance because of their arrangement of energy momenta within their fields. Of course, classically they've been defined, the chem field itself has been defined as a kinetic energy and a separate magnetic moment, which is what led to the idea of, in special relativity, of the magnetic moment being created by relativistic distortion of matter geometries or spherical charges. Again, we've shown in the previous lectures that the point charge is no longer spherical, it has real spin, and it's made up of 4 pi tetrons, standing wave energy geometries. And equally, the separated magnetic moment and kinetic energy is in fact two distinct properties. A longitudinal measurement of kinetic energy is a longitudinal measurement, or the photonic measurement of the field, and the transverse measurement is a measurement of the charge geometry of bosons, or the magnetic moment. Again, they're square energy fields, and the formulation that exists within physics currently in the textbook still applies. What has changed is obviously the geometry. So just like a boat in water is pictured on the left, or a supersonic plane breaking through the sound barrier on the right, in both cases we have particles of mass matter, and the energy of their motion is stored in their velocity and creates a wave field in proportion to their velocity. So it's an identical analogy. It simply takes it back to, strips away the probabilistic statistical mechanics of quantum mechanics and QED, gets rid of the infinities, and brings us back to a classical reinterpretation of what is in fact happening at the quantum level for particles in motion, thus removing the mystery. We also showed how the fractional changes of energy within any renormalized or square energy geometry of the chem field results in the spectral color lines. And not only in the second lecture, the lecture prior, we also did this in separate lectures as well on spectral lines and quantum chemistry. Again, we showed how the mathematics is all exactly the same, but where the mathematics couldn't be interpreted in the sense of a physical explanation for the math, the geometry gives us that physical explanation for the mathematics of Rydberg's constant and his formula for spectral lines. Of course, we showed that in the case of wave functions within QED, that the energy within energy momenta within any EM or EM field or EM photon follows a normal distribution or a bell curve within its charge geometries. Of course, the charge being the quantized angular momentum of the photon or EM wave, and the linear momentum being its square root. We've of course shown how voltage is related to the energy momenta, how we can measure in terms of transverse odd-numbered geometries or bosons of energy to give us how many quanta are within the field and the quantum levels. We can show the energy levels with their color coding for the n levels, the square numbered n levels. And we've of course shown how the frequency wavelength relationship relates to the velocity of propagation, and how we can combine all of this with longitudinal measurements to give us the statistical probability of wave functions for photons and EM waves or fields of energy momenta. We showed how Euler's formula relates back specifically to photons of energy, and each expression of Euler's formula is in fact an expression of charge, with e to the I pi the square root of -1 being the linear momentum of a negative charged field, and e to the I pi plus 1 equaling 0 being a mathematical description of a photon where positive and negative charges come together to form a tau geometry of the photon itself or of EM waves in general. Of course, in doing this with both transverse and longitudinal quanta arrangements or distributions within the charged energy geometries of mass, energy and matter, we have of course shown that this is the foundation for the statistical and probabilistic mechanics of quantum mechanics and QED, where it's normally expressed as being a chance of a particle being there or not being there. This still applies, but we can see the physical geometries of the energy distribution as highlighted at the bottom right. We can see that we start from the center, the amplitude of the wave, or its square root linear momentum of the charge. We can see its amplitude here in this case being 6, or in fact it's that in fact should be 8. 1, 2, 3, 4, 5, 6, 7, 8. Yes, the numbering at the bottom is incorrect. It should be an 8. And that as you move laterally from the amplitude of 8 in either direction, you decrease the probability of finding a photon of light or energy by 1, n minus 1. And this of course, n minus 1 from the central or mean distribution amplitude, is in fact how we calculate a normal distribution or generate a bell curve. Of course, the smooth curvature of the bell curve is in fact due to the fact that when we measure these systems with macro measurements, we can't be exactly precise. So we simply obtain our data and then round it off to generate the curve. In fact, at the quantum level, they are equilateral geometries creating these bell curves. So in doing this, we've shown how the fields come together. We've shown that charge is the main is the result of the equilateral geometries. The square numbers are in fact the result of equilateral geometries, and it's these charged geometries that give us all the properties of quantum mechanics and QED with respect to all measurements of mass, energy and matter within those disciplines. Of course, as we touched on, whether it's a EM wave or whether it's a chem field, makes no difference. It's just a differing geometry in terms of the mass, energy and the momenta distribution within that. As the velocity increases for a particle or for a field of energy momentum moving through a medium, the number of quanta changes in direct proportion to the square of the velocity, and the net momentum of the energy momenta within this field gives us the resultant velocity in relation to the mass matter of the particle that it's accelerating. In this case, this follows Newton's second law, F equals ma. As we apply more force, we increase the energy momenta quanta within the field, which gives us a change in velocity or an acceleration. Of course, all these changes are affected by adding or removing odd-numbered transverse bosons from the field. You can't remove the photon, you have to remove it via a boson, because you must maintain the square number of quanta within the field in relation to the velocity. So it must be removed as bosons from the field. Of course, in QED, in the previous two lectures and other lectures contained in Tetryonics, we clearly show all of the quantum mechanical properties and energy mass energy distributions of photons and EM waves. Whether it's the bosons or photons, the linear or the angular momentum, the mass or the energy, or the distributions of all of those properties within the charge geometry, Tetryonics can reveal all of the mathematics and their relationships one to the other through the geometry. So with all matter in motion, their energy is created through the addition of bosons into their chem fields to create that motion, or as a result of the force applied to the particle itself. Even though this energy is added as a boson or an odd number of quanta, it always forms square numbered energy momenta, which is this, of course, the square of the velocity that it produces. And we typically calculate additional properties of these bosonic fields as photonic fields or longitudinal mass energy measurements. Although there is a difference between the two apart from their direction of measurement, and the difference, of course, is that it takes two quanta to form a photon quantum of electromagnetic energy. But we can express all the properties of QED with Tetryonics using a new schema where we have the charge and matter at the base of the wave function symbol, because they are invariant to velocity. The charge does not change as we increase the velocity, nor does the mass matter geometry of the particle itself. What does change is the mass energy momenta content of its chem field, or its kinetic energies. And by adding the kinetic energies to the mass energies of the matter, we can create a relativistic mass energy measurement of the system. But again, as the velocity increases, the mass matter of the system does not increase, only the mass energy of its chem field. I will continue to repeat this for quite a long time. It's an extremely important point, particularly where we're discussing special relativity and how Tetryonics re-explains and rebuts all of not only special relativity but general relativity as well. Of course, as we mentioned, where we have a chem field with energy momenta in it, we can accelerate a particle, whether we apply the energy momenta via electrical forces on the matter and accelerate it as a current, or whether we apply a direct force, physical force, by pushing the particle, in which term we'll create a correspondent chem field. But in all cases, the number of quanta is equal to the square of the velocity. And this relationship is a geometric relationship, again clearly showing us that C is not a limit. E equals mc squared in Einstein's mass energy equivalence formulation is a specific example of mass energy relationship. It relates specifically to the, not only in the first case, to the geometric relationship between scalar energy and measuring that energy per unit of time, or per c squared, to give us the mass, which again gives us the formulation E equals mc squared. But it also relates in the specific cases where the energy itself is in motion, at the speed of light, i.e. the natural speed of energy. In this case it would be a photon or an EM wave whose energy content is equivalent to its mass through the speed of light, the square of the speed of light. Its momentum would be related through the speed of light. And again, these are terms for EM waves which are hotly debated. A EM wave or a photon has mass because it has energy content per unit of time. It is a massive energy field, and it's a massive energy field, energy momentum field. Again, because it has mass, because of its geometry and its measurement of energy, the geometry tells us that the square root of that field will also be its linear momentum, or E equals mc, in the case of photons moving at the natural velocity of energy. All these relationships still hold for photons and EM waves. They also hold for where energy is released from the collapse of matter geometries, or standing wave geometry is turned into radiant energy forms. Where this occurs and matter is converted into radiant energy, the energy within the standing wave was already moving at the natural velocity of energy in the standing wave geometry, so it will be released with a velocity of c. And again, E equals mc squared still applies for that photon or EM wave while it is moving in a vacuum. Should it encounter another medium, air, plasma, or water, or glass even, in the case of prisms, this velocity will change due to the superpositioned wavelengths and energy momenta within the field, and the field will disperse into its constituent colours. So again, the frequency wavelength velocity, because as expressed to the energy of the equilateral field, creates a specific velocity for any medium. So it's more appropriate within Tetryonics to stress always that the energy of any field is E equals mv squared. This takes away confusion regarding what medium it's moving in, and it takes away confusion regarding what you're actually measuring or determining. In all cases, we just simply say E equals mv squared, and then we calculate for whatever particular property or physical property is generated by the frequency, wavelength, and geometric relationships. But as you can see, there is no limit of c to the geometry. In fact, this geometry can continue on to any velocity at all, providing you have sufficient energy momenta to add to the field. A velocity will be created that's in proportion to the square root of the energy momenta of that field. So in the case of relativistic kinetic energies, or the energies of the chem field that result from the motion of matter, we can see here two charged particles in motion with their chem fields. They have identical chem fields in both cases, resulting in a velocity of motion. But due to the net charge of the particles in motion, the mass matter geometry itself, we have a differing magnetic moment. And again, if you were to reverse the direction of, say, the electron at the top left, to the opposite direction, you would in fact change the magnetic dipole arrangement, which of course affects whether it is a parallel or anti-parallel energy or moment with respect to any nuclear or external field. And this is what gives us up and down spin. There are only two values. It can either be going one direction or the other, or have one charge or the other. So we have an up or down spin, again discussed in other lectures, particularly quantum mechanics towards the end, and spectral lines is discussed again. But the half spin of electrons is not in fact a half spin. A full rotation of the electron geometry brings it back to its start point. It's a spin of 1 if you measure it in that sense. However, you could mistake it for a spin of 3 because it has a 3-phase pole geometry as shown here at the bottom of the page, where each pole or rotor arm is the exact geometry of the other two. So a 120 degree rotation in the case of an electron would in fact, if you were measuring the dipoles, could easily be mistaken for a 360 degree rotation. Again, quantum mechanics would describe it as a half spin, or QED would, but in fact it's a full 360 degree rotation, or a spin of 1. All the spin numbering that applies to quantum mechanics and QED should be re-evaluated in light of all this. Tetryonics gives us the answers. We can use the Tetryonic geometry to give us all the answers for the spin up and down and the spin numbers. But the existing spin numbers determined by the magnetic moment orientation should be dropped from use completely, preferably, or looked at carefully to be reassigned in light of the Tetryonic geometry. Again, the geometry explains everything and how the mistakes came about. But in all cases, the energy momentum within the field is proportional to the square of the velocity it produces. And this is an mv squared. In the case of chem fields, we're talking the matter for m, not mass. So it's the mass matter of the particle by its velocity squared. And if you want a measurement of kinetic energy alone, again, this is the photon longitudinal measurement of the field. It's simply half of the field strength, and the other half of the energy momentum goes into making the magnetic moment. This is obviously in complete contradiction, again, to special relativity, and this is the reason why this lecture was brought up and has been done, because again we're showing where relativity was founded on mathematical assumptions, particularly Lorentz contractions, the changes of frequency wavelength for changes of velocity with respect to c, and it used c as a limit, a constant speed of light. While the constant speed of light remains a constant, or the natural velocity of energy as we describe it in Tetryonics, it is no longer a limit. The limit was derived by mathematically graphing the mathematical functions of Lorentz's corrections, and in fact this isn't the case. In fact, Lorentz's corrections allow us to calculate frequency and wavelength changes in the chem field for any change in velocity. I often think of it as just as a scaling factor, how efficient the energy momenta are at producing a particular velocity for any given mass matter particle that they're pushing along. We can in fact go faster than c by increasing the number of energy momenta per unit of time to the point where the linear momentum of the energy momenta, or the square root of the scalar field, gives us a velocity in excess of c. And again, as we see down here, linear momentum, the square of the linear momentum gives us the energy of the kinetic field. Or if we divide it by 2, we have the longitudinal or transverse kinetic energy or magnetic moment, or i.e. kinetic energies of the field. Both these halves add up to a total field. Again, E equals mv squared. Of course, as I just mentioned, with the scalar and linear mathematical approaches to measuring mass energy changes due to velocity, we developed the Lorentz corrections for velocity. These were what formed the foundation for special relativity in Einstein's formulation. And what he did was, due to the Michelson-Morley experiment showing a null result for the ether, he then, these formulations were generated by Lorentz and Fitzgerald to give us a correction factor on the basis that the velocity must have changed due to its direction of motion, in an attempt to explain the results obtained. In fact, Tetryonics just explains the results in a completely different manner, and that is through the natural velocity of energy, which is a wavelength frequency relationship, again, all resulting from the equilateral geometry within of energy momenta. There will be discussions and lectures on that aspect as well. But what was derived by Lorentz, and it's become known as the Lorentz corrections, is this relationship between not only a scalar relationship between velocity and the speed of light, but also between the scalar energy required, or the changes in scalar energy that result. Where a couple of mistakes were made, even in the Lorentz calculations, was that it was not recognized that these formulas applied only to the chem field, because the chem field obviously wasn't known. So what was done was these were applied to photons of light, in the case when Lorentz first devised them to explain the Michelson-Morley results, and then Einstein applied them to mass matter energy geometries. So he extended it from just purely light considerations to the consideration of matter as well. And he did this by lumping mass energy matter into his relativistic stress energy tensor, and considering it all forms of energy, all energy waveforms, as a energy density. So the energy that's contained in the mass energy within this geometry, 1.2 by 10 to the 20 quanta, or Planck quanta, is then simply added to the 625 quanta within the chem field, giving it a velocity of 25 in this case. So what happens is the highly concentrated standing wave mass energies of the matter are spread out in the stress energy tensor and mixed with the mass energies of the chem field. In relativity, there is no distinction between mass energy of chem fields or the mass energies of matter. There is no distinction between mass and matter, and no distinction between matter in motion and its chem field. These are all things that contribute to erroneous assumptions, or in particular the development of relativity theory from the mathematics of velocity changes. And again, it led to the assumption and the claim that in the case of relativistic velocities, the Galilean or Newtonian velocity addition no longer applies. If you follow the boson geometry, or the quantum levels of all energy fields, you'll see in fact that the velocity addition continues to apply. What happens is the energy, or the bosons, the odd number quanta required for each square energy momenta within the field, requires more and more, obviously n plus 1 in each case as you increase the energy. So in this case we have 47 followed by 49. We would then need 51 for the next energy level. Accordingly, as you increase the velocity, you get less and less efficiency at increasing velocity itself, because it's a square relationship. In this case we can see it through the equilateral geometry, not the curve that's normally used. The curve would tend to imply that it becomes more and more linear and slopes upwards higher and higher to the point at C where it no longer contributes. In fact, using the equilateral geometry, you can see that energy, every increasing boson that adds to this, increases the velocity. We will continue this till we get to C, where we would have C minus 1 at the speed of C for the boson just prior to achieving the velocity of light. And then an additional odd number quanta after that, c plus 1, would give us a velocity in excess of the speed of light. But in all cases, the velocity is determined by the number of energy momenta quanta within the field, not the matter itself within the chem field, and the wavelength, or the frequency, will obviously increase as we add quanta, and the wavelength of these particles will decrease. This is what's being described with Lorentz corrections. The Lorentz corrections apply to the chem field energy momenta, not to the mass energy momenta of standing wave geometries. They are Lorentz invariant, as I've expressed here. And again, instead of length contraction, they're best termed as wavelength contractions, because they refer to mass energies in 2D chem waves. So they're a wavelength contraction, much more appropriate. And in the case of time corrections, again within other lectures, we show time to be a measure of charge, or in fact the quantized angular momentum, the equilateral geometry, per c squared, which is charge. Alpha per c squared is charge, but again, alpha, the quantized angular momentum, is square meters per second divided by c squared, gives you a unit of seconds. So we can clearly show that time corrections are simply reflective of the equilateral geometries of energy within the field, all affected by Lorentz corrections, and correctly modelled, by the way, with respect to c. But in fact, the 1 here, which is just c squared over c squared, can in fact change to be c plus 1 over c squared, etc., giving us faster than light velocities. We of course showed how the moving magnet conductor problem was explained in the previous lecture, using the equilateral energy momenta within the magnetic fields. A positive and negative field, charge field with energy momenta come together to form the magnetic dipole, or the permanent magnet. A permanent magnet is a permanent magnetic dipole. It will have positive and negative fields. And it's the energy momenta within these fields, even though the scalar fields themselves are neutralized by their positive and negative charge and their even a change of Lorentz coordinate system, looking at it from the other side, will give us a positive and negative, the opposite. So it is completely neutralized in the case of sensing this field, but it still contains positive and negative energy momenta. And these energy momenta, or quanta within the field, have electric fields, and they still produce electric forces or electromotive forces on charged particles. So as we move, again this illustration should be turned sideways for the loop, as we move the loop from the top to the bottom of the page and vice versa, backwards and forwards over the magnet, it's the geometry of the E and the M fields that the magnet itself creates will produce a force because of the separated charges of the E fields. The E field will affect any charged particle within it because of its divergent and convergent energy momenta. And this is what creates the EMF in a conductive loop as it moves above or around a magnet, which forms the basis of all our electrical industries and motors. Of course, this is expressed currently as Lorentz force, for example, which describes the force that's created due to both the velocity and the strength of the electric and magnetic fields. Again, we show all of this through the equilateral geometry and the square roots of those geometries within the field. Relativity and Einstein explained all of this as a changing frame of reference, i.e. where Faraday said that wherever there exists a magnetic field there is an electric, and where there's an electric there is a magnetic, which is in accordance with Tetryonic geometries, and the fact that they vary with respect to each other, 90 degrees out of phase. We can see all this with the geometry of Tetryonic fields as pictured here. He described this geometry as being the result of the changing velocity. As the velocity of a charged particle increased, it would create a magnetic moment. We now show this to be increasing energy momenta within the chem field. Half of the energy creates the magnetic moment, the other half goes into kinetic energies. So in doing so, we eliminate spherical point charges with tetronic matter quanta. We eliminate mass energy matter being lumped into a stress energy tensor, and we separate them into mass energies and matter. We also separate standing wave matter geometries from two-dimensional waves of energy or chem fields. So we can distinguish between all forms of mass energy matter by their geometry, and all their physical properties are determined by their geometry, not by any relativistic change of frame or inertial viewpoints. So again, what was described by relativity theory is completely replaced and disproved or rebutted using Tetryonic geometry. As we discussed previously, as the velocity increases of a point particle, relativity theory says that the spherical point charge is distorted. It's contracted along its direction of motion in line with Lorentz's correction formulas, and it's this distortion in the transverse sense that gives us our magnetic moment. And in earlier physics it was referred to as a transverse force, or the magnetic moment was referred to as a transverse force. The longitudinal force was described as kinetic energies, momentum, etc. Tetryonics now redescribes all of these. The magnetic moment still remains a transverse force. It's half of the energy of the chem field. Again, the other half of the energy is the kinetic energies. The transverse forces are bosons. The longitudinal forces are photon measurements of the square equilateral energy momenta within the chem field. We separate chem wave geometries out from standing wave matter geometries. And of course at all times we take great care as to what we're measuring. In this case we can see c squared, so in these cases these formulas relate to the chem energies, not to the standing wave matter. If we wish to calculate as per the stress energy tensor and include the mass of the matter, the mass energies of the matter, as well as the chem fields and their interactions, we would have to change to a spherical spatial coordinate system to accommodate the 3D matter, and that would be c to the fourth. In fact, this becomes handy where you are modelling Coulomb forces and Lorentz forces between particles in motion, because these c squared chem fields with their electric and magnetic forces are c squared, require spatial c squared spatial geometry or coordinate systems for measurement, where they superposition between the electric and or the magnetic. They require a c to the fourth, which of course is the spherical coordinate system, but because they're c squared on top of c squared where they're superpositioned, they give a natural c to the fourth coordinate system that balances out with the c to the fourth coordinate system for mass matter. So again, where we have superpositioned or fields, particles interacting via fields, this c squared that's currently here will become c to the fourth where it interacts, and this allows us to calculate everything as a stress energy tensor, as a purely as a energy density without respect to mass or matter. We don't do that in Tetryonics. We specify mass and matter and energy in all its forms along with its geometry, and we then show that Lorentz squared is a scalar measurement, and Lorentz correction itself in the direction of velocity is a linear measurement of energy within those fields. So we can show that in the case of spectral lines in particular, or any particle that's accelerating, and that includes increasing as well as decreasing velocity, the spectral lines, or the energy that's emitted from the particle, is the result of the kinetic energy changes, or changes of kinetic energy in that field, not within the matter geometry itself. The mass matter of particles remains invariant to the Lorentz contractions of EM waves. We can show this from either direction because we now have three-dimensional modelling available for all particles. In this case we have leptons. We can show that in the case of a static particle or a lepton, electron, negative charged lepton. We can see the charge of the particle itself, and we can see its electric permittivity and magnetic permeability, or longitudinal transverse forces, energy momenta, within its charged geometry. Again, while we have single charged geometries drawn here, each geometry has 1 by 10 to the 19 quanta within it. And this is, of course, is the Compton frequency. And due to that large number of quanta within the field, they obviously have shortened wavelengths. And this gives us, if you like, the fabric for matter. It gives us the solidity that matter gives us. They're standing wave geometry, so even though we have a fixed geometry, the energy within those fields is propagating. If you build the models, and again I encourage you, you'll see that the electric field, as shown at the bottom here, propagates into a magnetic pole of a dipole field. And the dipole fields, of course, supply energy to the electric field, and this circulates around. If you wish to map the direction of energy propagation, you simply take the square root of the field to indicate the linear momentum and the direction, and you can see the direction that it's propagating in through the standing wave geometries. And this is what gives matter its solidity. Of course, we always express the energy fields of matter in motion as a chem field, and it's mv squared, or matter, mass matter velocity squared, giving us the total energy of that field, and we can quantize that field obviously to give us the Compton frequency and the de Broglie wavelength for matter. And this is what de Broglie did by dividing Planck by the momenta of the system, etc., in his thesis. But again, we can always relate it back to Lorentz's formulations for relativity, or relativistic corrections, in the linear direction using the linear formulation, or for the total field itself for mass matter, or EM mass energies of the EM field. We can do it as a scalar measurement as well. Again, noting that charge is invariant to any motion, as is matter itself. So they don't change. The charge and the mass matter of the object does not change. Or actually, I should say the mass matter of the particle does not change, but its chem field mass energies does. Again, they're neutral, so there's no charge change for quanta being added, even though they are in a charged field. This charged field has exactly the opposite charges when you change your perspective and look from the bottom up instead of the top down. You'll find a positive charge field being represented, so it's completely neutral. But what does remain is the magnetic dipole. When you look at this as a south-north, the underside will of course be a north-south, and this gives us a strong magnetic moment for any particle in motion. So even though we neutralize the charges and they remain invariant for motion, we in fact develop a stronger and stronger magnetic moment as a result of the energy quanta being added in the relationship of square energies to the velocity. So Tetryonics shows all of the features of special relativity. It does away with the problems of special relativity, gives us a finer view of mass, energy and matter, and it explains the problems inherent in special relativity in terms of QED and quantum mechanics, as far as energy probabilities, wave functions. There's many others I just can't think off the top of my head. I've been blinded. A lot of the features that we've discussed in the previous 3 lectures are all explained using tetronic geometries. In fact, all of the physical features are explained. So in doing all of this using the geometry and explaining quantum electrodynamics using tetronic geometry, we not only validate relativity theory where it's correct, but we show where it's incorrect and provide a direction forward with testable hypotheses so far as geometry itself is concerned, insofar as where the geometry shows us that the mathematics has been incorrectly extrapolated. This is obviously clearest in electrodynamics, where we have fields of force. Maxwell was the first to start looking at this. Faraday expressed magnetic and electric field lines as fields of force. Maxwell united separate electric and magnetic fields into a contiguous electromagnetic field. He was a great believer in the fact that if you develop a mathematical model of something, you should be able to build a physical model to represent that same system. And without it, your mathematics may indeed be flawed. In Tetryonics, we show that where he developed a series of counter-rotating hexagonal geometries with idler wheels between them to represent electric and magnetic forces, transverse, longitudinal. In this case, what we've done is we've taken the same principle, applied it to the equilateral geometries of chem fields, and this applies to matter geometries as well, the charged fascia, because they are exact same equilateral geometries. All that changes is the number of energy quanta within the geometries. But in the case of chem fields, where we are talking about lines of force between charged particles, as we increase the velocity or the charge of a particle, we have to increase the energy momenta within the field. This, of course, is a two-dimensional neutral electric field with a distinct magnetic moment. If we have a static field, we would have another field in the opposite direction to give us cancelling energy momenta to create the static field. In this case, we've got a particle in motion, so we're only looking at one direction. Of course, the quanta is always the square number of the velocity of the field itself, of the particle itself in motion, and this gives us an extended field of force out from the particle itself. This extended field of force obviously has divergent and convergent energy momenta within it. And the interaction between these energy momenta between one field and another gives us our familiar Coulomb force or Lorentz forces, electric or magnetic, depending on their angles of interaction. If we model these energy momenta and their quantized angular momentum, the equilateral geometries, with these rotating loops of electrical energy for the zero-point fields, we can see as we increase the energy or the velocity, we have to increase the energy. So obviously we have to increase the velocity in square numbers. We model them with negative charges rotating to anti-clockwise, positive rotating clockwise, and we can quickly see, looking at this illustration, what Maxwell was trying to draw in his analogy, physical analogy of fields of force. In this case, we have a series of wheels rotating against each other. The anti-clockwise rotation of the negative charge angular momentum will turn the positive charge angular momentum in a clockwise direction. And again, the clockwise direction of the positive charge will result in anti-clockwise directions of the negative charges against it. So the positive charge in this case acts as an idler for the negative charge energy momenta. Again, these are all analogies. There is no physical rotation of energy. The energy, of course, is the result of the equilateral geometries, but we can model them as a rotation of energy. We increase the quanta, we increase the positive, the divergent negative, and the convergent positive energy momenta quanta within the chem field, and we get increasing numbers of positive and negative idler wheels within this charged geometry. And again, if you continue the process down through all the energy levels that are possible, it continues all the way through. And in all cases, any motion of either a positive or negative charges anywhere in that field will result in the correct direction of motion for all the positive and negative charges around it. Rotate any positive charge, it will create a anti-clockwise or counterclockwise motion in all the negative charges. Or conversely, rotate the negative charge anti-clockwise, it will create clockwise rotations in all the positive charges. This is a perfect analogy for what Maxwell was trying to achieve when he devised his when he applied lines of force or fields of force to his equations. Where he may have struggled, obviously, is the fact that square numbers are equilateral geometries. So even though he may have been able to get this clockwise, anti-clockwise idler wheel arrangement going, as would have been the case here, he probably would have persisted with circular geometries, as physics and mathematics has for the last 3 centuries. When in fact we have equilateral geometries creating all our physical forces and all the manifestation of energy in the forms of mass and matter. Looking closely at these fields of force, we can now show, as we do down the bottom, the chem field, which is mv squared, it's the energy of the chem field, is made up of positive and negative, divergent, convergent energy momenta. The square of this creates our linear momentum in the system. And we can draw them either as electrical fluxes of energy, or energy momentum, quantum angular momentum, or we can draw it in terms of the equilateral geometries of positive and negative Planck charges. But in both cases, wherever they exist as a chem field, they result in the motion of particles, as drawn at the center right hand side. Apply a chem field to a particle, or a chem field worth of square energy momenta quanta, and the particle will gain a motion and a magnetic moment. But the mass matter of the particle itself will not change. Of course, the velocity that results is determined by the number of quanta within the field, and this of course changes the frequency wavelength relationship of that field. Where the two particles are in motion, obviously their fields of force that are generated by their chem fields can interact with other fields of force with separated charges in other locations. And in this case we have two particles heading towards each other, laterally offset. They could head towards each other directly head on, in which case their energy momenta, the divergent property of their chem field, would oppose the divergent property of the other chem field, and what results would be opposite charges repel. They would first start to interact. As the fields grow closer and closer to the charged particles themselves, it obviously increases as the square of the distance. The diamond geometry tells us it's an inverse square force for the electric force. So it's an inverse square force, and it's also an inverse square force between the magnetic poles. Between the magnetic dipoles, it tapers off as an inverse cube law. But between the Coulomb force, which is an electric field force, and the Lorentz force for laterally displaced particles, it's an inverse square force, the strength of which is determined by their distance apart, or the overlapping of their chem fields. Further apart they are, the weaker the chem fields interact. Closer they get, the stronger or the more energy momentum per boson or transverse energy level is present to act upon the other field. If this one in fact was a positive charge, they will be drawn closer together, because the superposition fields would in fact act constructively to increase the energy momenta directions of the attraction. Again, opposite particles would then attract, as opposed to being similars repelling. This is our familiar law of interaction. So we can show that the chem field orientation of electric and magnetic fields gives us Coulomb's force and Lorentz's force, dependent on the angle of interaction. And of course the total energy of the chem field will give us our linear velocity. Changes in the field gives us changes in linear velocity, and vice versa, giving us spectral lines. This is then represented down the bottom here, where we've expressed it in terms of half energies, or the kinetic energy in this case, or the magnetic moment. You don't get both interacting at the same time. because of the geometry. You can see here as particles approach head-on, it's only their kinetic fields that interact. So therefore it's the electric component, and that's the Coulomb force between charges. Laterally, as they interact side by side, they interact via the Lorentz force, or the transverse magnetic mass energies. And this is a different force to the Coulomb force. It's a lateral force versus longitudinal, and it's an magnetic versus an electric force. But in both cases, they're the result of superposition fields, or the square of the energy momenta within that field. Now in the case of Lorentz force, as drawn here, we can express this as just the kinetic energy squared, obviously. It will never be the total energy squared, because you can't have both operating at the same time due to the geometry. And we can express it as in terms of linear forces between the particles, i.e. their momenta and the velocity of the particles. And again, it's half the energy of the field, so you've got to divide by 2 for the kinetic energy. And likewise, we can quantize that energy using mass alpha, or Planck's constant, as in the unified field equation, to give us the energy of the kinetic fields, which is obviously half of the total energy of the field. So here we've quantized it. Again, it reveals the unified field equation for energy divided by 2 for the kinetic energy or the magnetic moment. It applies to either. Ke does not always mean kinetic energy. In Tetryonics, we use it to refer to kinetic energies, which can be either electric or magnetic. They're equal in strength, and again proportional to the velocities. So these equations apply equally to kinetic energies, whether they're Lorentz force magnetic or Coulomb force electric fields. But in both cases, using the unified field equation for energy divided by 2, we can show it as either Planck's constant by quanta, or mass by velocity. Again, this relates back to measuring the momenta-velocity relationship. But they are distinct geometries in both cases. In this one, we show that it's actually the squaring the alpha constant, or the geometry, that gives us the interaction. And that's what Tetryonics reveals that relativity doesn't reveal. And that is the alpha constant, the fine-tuning constant or coupling constant, that's hidden within Planck's constant. Tetryonics shows it to be the equilateral geometry, the quantized angular momentum, again responsible for the fields of force, again responsible for charge. It's this hidden alpha constant, or geometry, for energy, again energy per second is mass, that gives us Planck's constant. Mass alpha can be reread as Planck's constant by quanta, or mass velocity in the case of classical energy. Tetryonics always formulates it as mass alpha mu, which can be read in either direction. But what it shows us is that the forces, normally explained with virtual particles in quantum mechanics and QED, are in fact the result of the energy momenta geometries within any field, or chem field particularly. It's the chem field that gives us our field of force, or the electrostatic field, which is just 2 chem fields together where the momenta cancels out. And it's the geometry of the energy quantum energy momenta within the field that allows us to exert force. Again, Planck's constant, mass alpha, is the quantum of action, the unit of force. So we can apply all this, and in both these cases all we're doing is re-expressing the classical formulation for energy, which is mv squared equals momenta velocity. That's the classical formulation there. We've just expanded it using Tetryonic geometry to explain that the kinetic energies, either magnetic or electric, Lorentz or Coulomb forces, can be re-expressed as a function of the squaring of the fields, or the superpositioning of 2 fields, 2 chem fields. By superpositioning these fields, we obviously square the kinetic energy, just as in the case of Lorentz force we would square the magnetic pole, or poles, 2 separate poles. poles, not a dipole. Only one side of the particle affects another particle. Hence why it's a square, inverse square force, not an inverse cube. In this case, the equation applies to both, but they are measurements of the same thing. One's a measurement of mass alpha mu, or mass velocity. The other one's a measure of, again, mass velocity by velocity, momenta by velocity, and in both cases they're squared. So where it was normally mass alpha nu squared, we have mass alpha squared nu to the fourth, and equally it'd be mass squared velocity to the fourth. So Tetryonic geometry again is showing us the exact formulation, and you'll see very shortly where the formulation mathematically is erred in calculating mass, energy, momenta for fields of force. Again, developing the standard equation as I just expressed it, mass squared velocity to the fourth equals E squared momenta to the fourth. These can be formulated in a number of ways, but Tetryonics uses the geometry, and this is what Feynman attempted to use with his Feynman diagrams. He used a diagrammatic procedure to model the particle interactions to give a semblance of order. We can replace all of the Feynman diagrams with Tetryonic geometries of mass, energy, matter fields, or geometries. And in doing so, we not only give the interactions, we can calculate the strength of the forces, which forces are present, and the mass, energy, momenta of both the chem field and the matter itself within the relativistic stress energy tensor describing the fields. In this case, the maths erred because where they have all of this, they simply subtracted the square of the momenta and the speed of light, the mass velocity relationship for fields of electromagnetic energy. They took it away when in fact it should be an equivalence. If you look closely at the formulation there under Feynman's diagrams, you'll see that it differs from the Tetryonic formulation. It's not a minus sign, it's an equal. Mass, energy, velocity, or mass velocity, or Planck quanta squared, is in fact equal to energy, which is in fact equal to momenta velocity. Looking closely at Planck's constant, as we've said, mass alpha is Planck's constant, kilograms quantized angular momentum. All energy has an equilateral geometry, and it's the geometry that gives us quantized angular momentum. That is to say, quantized angular momentum is equilateral geometry. It is also the alpha constant. It's been hidden within Planck's constant since its development, because Planck's constant has been expressed as h. And in fact, many textbooks will frown upon you separating it out as an expression of mass quantized angular momentum, or angular momentum particularly. And again, it is not angular momentum, it is quantized angular momentum. It has the same units, but it is an equilateral geometry, not a vector rotation about a point. You can see that we've drawn the vector rotation again about a point within the 0 point field to reflect the short-circuited quantum inductive geometries. But it is not a vector rotation as classically thought of in the case of angular momentum. It is in fact the equilateral geometry. And this of course is borne out again where we look at the number of equilateral geometries, or the alpha per c squared. Alpha per c squared gives us quantized charge 1.335 by 10 to the minus 20 coulombs. Of course, multiplying this number by 12 for the charge geometry of a lepton, in the case of negative charges, will give us the elementary charge of an electron. Adding 36 positive and negative charges together in the charge geometry of baryons will either give us 24 positive and 12 negative, or a +1 elementary charge for protons, or an equal number of positive and negatives, giving us a neutral charge for a neutron. This pattern is repeated throughout, again showing that it is the charged geometry of mass, energy, matter that is important. Mass energy by itself, without understanding the geometry and the positive and negative characteristics of Planck's quantum, does nothing. But through its geometry of its equilateral geometry, its quantized angular momentum, it creates a charged geometry with its magnetic dipole. This dipole allows the weak force interaction between quanta, and the electric field is the strong force between parallel charged fascia within atoms. So it's the geometry, the equilateral geometry, the alpha, within Planck's quantum, that gives us all the basic fundamental forces within the atom, and it gives us charge as well as the geometry itself for all our physical fields. And that's why it's so important. That's why it's stressed in the golden colour. It's the key part. It's the hidden geometry that gives us the hidden constant as it's expressed. Of course, again, in the case of Planck's constant, the energy content can vary, well, not in one quantum, but within a field. The amount of energy can vary, and this will affect the mass, but the geometry always remains. It's a fixed equilateral geometry, so it's critically important in understanding QED and in reinterpreting and rebutting special relativity. Of course, where the alpha component of the fields, where fields superposition and interact, whether it's from electrostatic fields or from particles in motion, the fields themselves will interact via the square of the energy of the interaction. In this case, we're again drawing Lorentz's force. Coulomb's force. Lorentz's force would be the lateral interaction of magnetic fields. But again, as Feynman described, it's a magical property. It's a hidden property. It's a geometric property within Tetryonics and within physics in general. But the square of the alpha, the squared geometries of the fields, gives us the strength of interaction. Firstly, it gives us the diamond geometry tells us that it's a inverse squared force of interaction. And secondly, we know from the energy momenta within these equilateral geometries, each geometry that superpositions, that it diminishes as the square of the distance. So we can quickly show that in most cases, where you have a diamond shape geometry resulting from field interactions, you have an inverse square force. Of course, we separate these fields out to look at the quantization of energy within the field, or mass alpha for Planck's constant, and looking at both in terms of charge and in terms of Planck's constant, we quickly determined the value for alpha is 0.0012 square meters per second. Of course, alpha measured per second will give us a measurement of charge, or 0.0012 divided by c squared gives us the quantized charge. And equally, we can refer it back to the pi geometry, the equilateral geometry, and we can say that the field is a 4 pi geometry of electric and magnetic forces. In this case, we're only referring to the electric forces or the magnetic forces in the case of a field, depending on their angle of interaction. And again, relate it back to 2 pi, and it gives us a corrected number for the alpha coupling constant. Traditionally, it's been expressed as 7.297 by 10 to the minus 3, or the inverse of 137. In fact, a lot of mysticism has been laid into this number of the inverse of 137, and again it clearly shows where the mathematical approach was erroneous and profoundly misleading. Obviously, we have a different value here. In the case of alpha, we have a value of 7.539 by 10 to the minus 3, or the inverse of 132.629. They're markedly different. Why they are markedly different is because the Tetryonic derivation and calculation of this alpha constant is exact. It gives us the exact value for quantized charge. It gives us the exact value for Planck's constant. It gives us the exact value for force interactions, both in and geometries, both in the case of Coulomb's force and Lorentz forces. But what it doesn't do in this example is it doesn't allow for blackbody radiation for particles being tested, and it doesn't allow for kinetic energy or chem field energies of motion, or the additional chem field energies of motion, because obviously in this case we're describing chem fields. This is the exact strength of the fine coupling constant. So where people have muddled over and been fascinated by the inverse of 137, strip away all the energies of motion or blackbody radiation for the particles interacting each other, so they're completely electrostatic and they have no blackbody radiation in an ideal situation, and these are the numbers that you get. This is the alpha coupling constant. It gives us, as I said, charge, Planck's constant, the strength of the fields of force, and it's all derived not from a mathematical basis, it is derived from the geometric basis, again highlighting that the geometry is the foundation. The mathematics is simply a language we've developed in an attempt to discover this geometry. So in this case, the alpha coupling constant is in fact the square of the kinetic energy field. In Lorentz's force, it would be the square of the magnetic field interaction. Again, these fields, the chem fields, perfectly describe geometrically Ampere's law and all the other laws that we use to measure the strength of this force. And it also applies with the coupling between electrons and baryons or deuterium nuclei in every element. Again, Tetryonics gives you the geometry of every single element, along with the energies, frequencies, wavelengths of all the spectral lines that are created through changes of chem field interactions between the particles and their energy fields within the atomic nuclei. And in doing so, we can also, and you'll see in the lectures on spectral lines, that we relate all of those properties of wavelength, frequency, energy, momenta, back to Planck's constant and back to alpha again. So it's not only in electrodynamics and quantum mechanics that we've proven the geometry to be correct, it's also within chemistry and spectral line emission, etc. Obviously, the inverse square geometry of superposition fields can describe a number of things mathematically, and this is what we see in physics. Newton was the first one to describe an inverse square law as being gravitation between two objects of matter, where you equate mathematically the mass matter of an object into a single equilateral field of force. You then do the same thing for the second matter object, express its mass matter as mass energy in a field, and superposition them. This will give you then a force, being the linear momentum, the square root of the geometries, between the particles. And you will note in the case of matter, it's always convergent. It always pulls towards matter itself. I'm not going to explain it any more than that at this stage, other than what I just have. This will all be explained again in quantum gravitation. But where we have an m squared field or a charge squared field, matter or matter squared, geometrically they still can be represented by diamond geometries, inverse square geometries. And whether you're measuring the force of gravitation or Coulomb's force between similar particles or opposite particles makes no difference. The field will still be a diamond geometry resulting from the superpositioning of the fields. In this case, it's reflective of the the Coulomb force and Newton's force. So it's the E field of the E field geometries of the fields themselves. It's ignoring, in the case of gravity, the magnetic field, as it is also doing in the case of charged particles, because due to their geometry, the magnetic fields don't interact in a linear direction. They only interact laterally. And this is a big point that will be pointed out in gravitation in a subsequent lecture. But in all cases, we can reterm this, whether it's charge or matter, as the alpha coupling, or the fine structure constant. And again, the number for the alpha constant is 7.539 by 10 to the minus 3. The coupling, or the superpositioning of these geometries, is what gives us our force, because obviously as each field superpositions, the energy momenta within these fields will interact, either constructively or destructively, in which case it'll either be an enhancement of the force or it'll be a repulsive force as they try to reject each other. Obviously matter has a lot more quanta, the matter of a planet, than the charge of an electron, and they have more energy momenta than the chem field as well. But irrespective of how many quanta are in it, it's the superpositioning and the regions of superpositioning dictated by the geometry that gives us our equations of force, either for charge or matter. In fact, sometimes matter can be described in terms of charge, but Newton was the first one to give us an inverse squared formula for force in his law of gravitation, and then Coulomb came along later and did his electrostatic forces. Obviously, if Newton had known about magnetic and electric fields, he would have recognized that they were an inverse squared force and used his formulation, and that's what happened with Coulomb. He recognized it as an inverse squared force, he measured it as such, and he gave the same formulation. It's the underlying geometry that gives us the math. Hence why Coulomb's force law is identical to Newton's force law, save for the fact one describes charge, the other describes mass matter, and they have a different coupling constant, which results from the number of quanta within these fields. This is a major breakthrough. It again clearly shows that mathematics by itself is simply a language. It's geometry that's the grammar. It gives us the reason for the mathematics, and it sets precise and well-defined rules as to how we can use the mathematics or manipulate the mathematics to give us additional information. By purely manipulating mathematics alone, you do not get the geometry. The alpha constant, as we refer to it, is hidden. It's buried away. It will never be discovered using the mathematics. You can try and calculate for it, which gives you 137, or the inverse of 137 versus 132, a wildly different answer. Or you can try to physically measure it in physical systems, in which case what happens there is even worse. What happens in the case of physical measurements is they rely on the mathematics, and they go seeking the value of 132. And as they get closer and closer to it, they refine to give themselves exact numbers. And this is what happens in quantum electrodynamics. QED itself does not predict the mass of an electron, but it's widely touted as being the most accurate formulation, mathematical formulation of quantum physics known to man, because it can go to 12 decimal places and be inaccurate. Well, unfortunately, the 12 decimal places it's going to are the wrong ones. They're seeking an answer and mathematically modelling it to give that answer. QED does not give the mass of the electron, so how can it possibly predict what the chem field energy momenta will be for the superposition chem fields to give the alpha constant for the coupling force? It does so to 12 degrees of accuracy, by putting the answer in for the mass of the electron and moving the mathematics around to give the answer of the inverse of 137, when in fact the answer was 132. This is a clear example where Tetryonics not only rebuts all of relativity on many levels, but also rebuts the mathematical approach to physics. Maths is the language used to describe the geometry. The geometry is the grammatical rules. It can't be any clearer than that. Looking at the coupling constants of Coulomb and Newton closely, again, care should be taken here not to assume that the mass of the matter itself is creating a specific field in proportion that is the same amount of energy quanta as its matter. It is in proportion. The larger the mass matter, the stronger the field. And that's an important point, and that's how Newton calculated his first off. He didn't know what the mass of the Earth and the Moon was, but he knew what force was required between the Earth and the Moon to produce the motion using the inverse squared law. So, using the mathematics above, he calculated what force should be there to create the orbit of the Moon around the Earth, and figured out that it was in proportion. It was 1 to 3,600, which of course is the square of 60. And he knew the proportions of one to the other and the force, so he calculated mathematically from the observations. It's not to say it's wrong, and where relativity stepped in a lecture to come, general relativity particularly, it was very accurate. But as we made increasingly more accurate measurements, we discovered slight inconsistencies in this formulation. On a scalar, macro scale, it's more than adequate, and it's still used today. Where you want to do bodies, again, with not only mass matter, but black body radiation and chem fields, additional fields of mass energy that interact, you have to account for all the energy momenta in all the fields. Relativity did this by lumping mass, matter and energy into a single stress energy tensor, as I've mentioned, and calling it an energy gradient, in which case he did away with the force between the objects and said the objects are simply following the curvature of the density. Both approaches mathematically are valid. They give you answers that we didn't previously have, but they do nothing to reveal the true geometry of quantized angular momentum, equilateral geometries, and mass energy matter itself. Tetryonics does all of this, and in doing so sets very precise rules of interaction and geometry, which of course highlight where the mathematics has gone wrong. In this case, all chem fields have equilateral geometries, so we can say that the energy of the fields divided by 2 pi gives us the Coulomb force. Superpositioning will of course be a 4 pi field, 2 squared, or 2 pi squared, giving us 4 pi. Of course the same thing applies to the Lorentz force between particles in motion, i.e. the magnetic forces. But in all cases the energy of the field, of the chem field, is mv squared. Whether it's the energy of motion, of a particle in motion, or whether it's just the energy of the field in the case of electrostatic fields, makes no difference. The strength of the force is determined by firstly the geometry, determines the angle, the interaction, the field of interaction, and secondly the number of energy momenta quanta, or Planck quanta, within the field, the energy of the field, determines the strength. So geometry for field of interaction, and the quanta, mass energy quanta, gives us the strength. And again, it's an inverse squared law, diamond shape, in both cases. So obviously Tetryonics, as a quick summary, down here so far as the constants, we have a chem field that has a kinetic component, kinetic energy component. It has a magnetic moment component, both of which are equal to each other. And they're comprised of electric permittivity fields and magnetic permeability fields. But again, the geometry dictates the strength of any field within that geometry. And they're comprised of divergent fields and convergent fields. We can, of course, as noted here, we can use this geometry, as Newton did, to model strictly convergent forces, or the force of gravity, acceleration due to gravity, which is the opposite to that of the electric force, which is net divergent. So divergent, net divergent electric fields or charges, and convergent forces for gravity. But in both cases we can use the same geometry to produce the same mathematics for force. All that changes is the energy momenta within the two equilateral fields. Charge obviously having less than matter, but in reality there is less energy momenta within the gravitational field than there is within the charge field. So charge is a quantum force. Well, it works much stronger at quantum, and it overwhelms gravity at the quantum level. And again, the charge fields are interactive. They have divergent and convergent fields, or energy momenta, whereas gravitational fields are strictly convergent. This also gave rise to a mathematical hypothesis or particle of the graviton. A graviton is shown not to exist. Looking closely at equilateral geometry itself and the coupling constant, alpha. Alpha per c squared, as I've mentioned, gives us charge, gives us the quantum of charge, I should say. So alpha per c squared, quantized charge, 1.335 by 10 to the minus 20 coulombs. As we add these charges together, they can do so either in odd numbered geometries, in which case there will still remain a net charge for the boson. Again, same amount, less than the elementary charge by 1/12. Or they can interact to form photons, where we have positive and negative charges coming together to give us a neutralization of the charge. The charge still remains positive and negative, as evidenced in electromagnetic waves, where we use them to accelerate particles through their E fields. But what happens is, because of their Euclidean or flat two-dimensional nature with and transverse Lorentz transformations to show us that the opposite of a negative is a positive, and the opposite side of a positive is a negative charge, the electromagnetic fields themselves, for the most part, are neutral, but they possess a photon, an Evans photomagneton, which is the magnetic moment of photons. And this is reflected again in EM fields, where we have a large number of photons coming together. Of course, in addition to neutralizing, coming together in neutral pairs, which is the natural state of energy, it always seeks to neutralize before it seeks to build larger charged geometries. But it can, in fact, after forming photons, can also form obviously the charged bosons, positive and negative, but it can continue on to form the foundational charged geometries of matter itself, as we've discussed in quantum mechanics, in which case the quantum charge becomes the elementary charge, or part thereof in the case of quarks. 12 charged geometries coming together will give us the elementary charge of either positive or negative. In the case of the positive elementary charge, it is in fact 24 positive and 12 negative charges that produce that. Again, the more natural state, where we have an imbalance of positive and negatives, is for neutral charges to form, i.e. neutrons and antineutrons, neutrinos, and you'll find that they're very common. But again, the alpha coupling constant, or the alpha in Planck's constant, mass alpha for Planck's constant, is the important point. it's been hidden inside Planck's constant. The mass, of course, being a measure of the energy per c squared versus the alpha per c squared. Bringing us back to our final quick discussions on the EPR paradox, Einstein, Podolsky and Rosen formulated a thought experiment, probably best part of 60 or 70 years ago now, where against Heisenberg's uncertainty principle, which says that you can't know the position and the momentum of any two particle or any particle at any time, they proposed the following experiment. They said if you in fact had two particles that were together at some stage, an identical charged pair set, it doesn't even in fact have to be opposite charges, they could be identically the same charges, and then allowed them to drift apart over time. If you measured this coupled set, and that's the important part, measured the coupled set at any time later on, you could determine the position of one particle and the momentum of the other. In this case we know the x, y, z Cartesian coordinates for this particle, and this particle here we know the momentum. They then suggested that if you knew this quantity, the position of this particle, you could use it to determine the position of the other one based on its momentum, and conversely, if you knew the momentum of this particle, you could determine the momentum and position of the other particle, which then hinted to them, and has remained ever since, to be a suggestion that at the fundamental level the understanding of quantum mechanics was not complete, and particularly as it was expressed through the uncertainty principle, that it was in fact possible to know both the position and the momentum of a coupled system as it separated over time, against what Heisenberg had expressed. Tetryonics shows this to be the case. It shows in the geometry, as we've shown here, that we can in fact measure the exact mass, energy, matter contents of any matter geometry for any particle, and we can determine all the physical properties of both the particle and its motion and its forces of interaction using the chem fields or the wave properties of the wave particle system. Obviously these systems were coupled at some point, and energy was put in to drive them apart. Using Tetryonics, we can then apply this knowledge of the system, the initial state of the system, along with the evolving state of the system, and its precise mass, energy, matter, content, and geometries to give us an answer for this problem, or this paradox. In the case of Tetryonics, you can see what happens here is energy was exerted into or placed into the system to separate these two coupled, or these two particles from their coupled state. But as they separate out over time, the energy that went into giving them their momentum and their mass velocity obviously remains as part of their coupled field. Again, the big E is the energy that went in to drive the system apart, or the particles apart from their lower energy state. This field remains as a field of information, if you like, between the two particles. Or you can just view it as the Tetryonic view of the mass energies that went into doing the work to separate the particles. In either case, irrespective of how you view it, we can still apply Tetryonic geometries to both the particle properties and the wave properties of both particles in the system as they move apart. And we can use our knowledge of transverse and longitudinal waves to show that while the energy field remains between the two, there's the ability to transfer information between the two systems in a as good as instantaneous fashion through the instantaneous action at a distance created by longitudinal energy, a longitudinal linear momenta of E fields in longitudinal waves. So this facilitates the near instantaneous transmission of energy on the state of one particle or the other, should you just wish to determine one from the other using their distinct properties. Use the momentum of this one to determine the momentum of the other, or the position of this one to determine the position of the other. Or conversely, you can use Tetryonic geometry to form an absolutely accurate model of this paradox and of the mass-energy-matter interactions of the complete system as it evolves over time. And again, use these geometric geometries and our understanding of mass-energy-matter to determine the distance between the particles, their velocity, the momenta, the changes in any property from one to the other, and how it's affected by external measurements. So Tetryonics gives us a complete understanding of the EPR process and of how entanglement works. It's the energy inputted in the system to separate the entangled particles that allows us to measure these properties and transfer the information of one measurement to the other particle, enabling this magical near instantaneous coupling and transfer of information that's often discussed of or about in quantum entanglement scenarios. Again, nothing magical, nothing mystical, and in fact it can all be drawn using paper, and the particles obviously cut out and folded into particle geometries. But all the mathematics that goes into it, and there's considerable mathematics, producing sometimes disagreeing results, can now all be rationalized back down to geometry again. And again, the geometry will quickly show what mathematics is appropriate and what mathematics is simply a supposition or something that should no longer be investigated. It's just a case of mathematics without the correct modeling is just a case of muddling along. What we want is finite quantum models for all mass energy matter interactions, and that's what Tetryonics gives us, as well as explaining all the properties that relativity attempted to explain over the past century. We can obviously apply this, as I just said, to all mass energy matter arrangements in the universe. Again, highlighting that space itself is just a region defined by a coordinate system. It's the geometries, the charged geometries of mass, energy and matter within that region that gives us physics and our universe as we sense it. Tetryonics allows us to build three-dimensional models of matter itself, as well as the two-dimensional models of wave fields and fields of interaction, fields of force. Tetryonics can't do that, nor can QED. Both theories rely on virtual particles, which we've discussed previously in this lecture. Tetryonics completely removes virtual particles and their infinities from quantum mechanics and electrodynamics in full, and replaces them with fields of force as described by Faraday, and is attempted to be modelled by Maxwell when he developed his formulation for the electromagnetic field. In a sense, if we had this geometry at Maxwell's time, we would be a century ahead of where we are now. I have a much clearer understanding of the mechanics involved here, both in terms of waves and particles, along with the fields of force and the energy momentum that creates this force. I trust, having listened to the lecture, that you now have a thorough understanding of the mechanics involved at the quantum level, and that you'll be able to apply these mechanics in the case of fields of force to many other regions of physics and science, i.e. gravitation, for example. There's a distinction between gravitation and chem fields of force, as illustrated here in the final picture. And that's obviously that the chem fields of force are equilateral geometries, whereas gravitational fields of force, as modelled by Newton, even though they follow the same geometries, in fact have a different physical geometry of their own. And this geometry, as described by Einstein's Special Relativity, is in fact more of a gradient. And it's a gradient that results from equilateral energies at the quantum level, but it is a completely distinct geometry as illustrated here. You can see the gravitational energy density of a single particle of matter, or a single element in this case, element 120, beryllium. And you can see that it's the gravitational field is the result of its matter geometry. It's not the result of the energy momenta within its chem fields. In this case, we have an electrostatic field. The particle isn't moving. We have two chem fields back to back, so the energy momenta that's created by them cancels out. It's black body radiation, if you like, or the electrostatic field. If they're both the same charge, it's an electrostatic field. If they're opposite charges, neutralized, it's purely black body radiation. All of these things will be discussed in greater detail, but as a summing up of the final picture here, and of QED and how we've rebutted special relativity, just want to highlight again that in Tetryonics it's a charged geometry that gives us the answers to all the force and mass matter energy combinations in physics. Odd geometries creating charge, even numbers creating photons of energy or longitudinal measurements compared to the transverse quantum levels of charge, and standing wave geometries of 4n pi matter. And again, the matter geometry, the mass energy of the matter, as illustrated here, is completely invariant to velocity. So if this field was to go from electrostatic to a chem field and gain motion as a result of the energy momenta in that chem field, the amount of mass energy in the matter, as shown here with its quantum levels, for the element would not change. Instead, it is the energy momenta within the chem field that determines its velocity, as I said, and it's the quanta of mass energies that changes in terms of wavelength and frequency within that field to give us a relativistic mass energy. This changing mass energy of the chem field plus the invariant mass energies of the matter add up to give us a relativistic energy. And this number matches Einstein's formulations exactly, except for where we have changes in the chemistry, Tetryonic chemistry. And it gives us a much clearer picture of relativistic changes of mass energy matter within Einstein's stress energy tensor. In fact, as the final comment, I can now confidently say that if you've followed this three-part lecture through to its end at this point, you'll see that we can in fact abandon relativity theory and its assumptions and premises and go back to Tetryonic theory with its equilateral geometry as its foundation, and correct the mathematics for all of quantum mechanics, electrodynamics, chemistry, and in fact we'll go on to show cosmology in later lectures and how Tetryonic geometry will in fact replace and correct both Newtonian gravity, as we've touched on here, as well as general relativity. It will show us the exact makeup of gravitational fields at the quantum level and again replace general relativity. So in this three-part lecture, I'm confident that we've completely rebutted special relativity as an appropriate way forward, and we can now move on to Tetryonic geometries of mass energy matter to give us more accurate measurements of physics and a much clearer and better understanding of physics and science for humanity as we move forward.